The National Electrical Code, or NEC, provides guidelines for calculating electrical loads in various types of occupancies. For store-type occupancies, Table 220.3 within the NEC clearly specifies a minimum lighting load requirement. This requirement is set at 3 volt amps per square foot. This means that for every square foot of floor area in a store, the electrical system must be capable of supplying at least 3 volt amps to account for lighting. It is a minimum requirement. The purpose of this minimum requirement is to ensure that the electrical system is adequately sized to handle the lighting load in a store. Stores typically have significant lighting requirements due to the need to illuminate merchandise, create an appealing shopping environment, and ensure the safety of customers and employees. The NEC recognizes this and establishes a minimum load to prevent undersized electrical systems that could lead to problems such as overloaded circuits, voltage drops, and potential fire hazards. It is important to understand that the 3 volt amps per square foot requirement is a minimum value. In some cases, the actual lighting load in a store may be higher than this minimum. This could be due to factors such as the type of lighting fixtures used, the layout of the store, and the specific needs of the business. If the actual lighting load is higher than 3 volt amps per square foot, the electrical system must be sized accordingly. One of the key points to remember when calculating the lighting load for a store is that demand factors cannot be applied to this load. Demand factors are multipliers that can be applied to certain types of electrical loads to account for the fact that not all loads will be operating at their maximum capacity simultaneously. However, the NEC specifically prohibits the use of demand factors for store lighting loads. This means that the entire lighting load, calculated at 3 volt amps per square foot, must be included in the total electrical load calculation for the store. The reason for this prohibition is that store lighting is typically considered a continuous load. Continuous loads are loads that are expected to operate for 3 hours or more at a time. Because store lighting is often left on for extended periods, the NEC requires that the electrical system be sized to handle the full lighting load without any reduction for demand factors. When reviewing electrical plans for a store, it is crucial to verify that the lighting load calculation is based on 3 volt amps per square foot and that no demand factors have been applied. If the plans specify a lower lighting load or if demand factors have been used, it is important to bring this to the attention of the engineer and require that the plans be revised to comply with the NEC requirements. Failure to properly calculate the lighting load can have significant consequences. An undersized electrical system can lead to frequent tripping of circuit breakers, voltage drops that can damage equipment, and an increased risk of electrical fires. In addition, an undersized system may not be able to handle future increases in the lighting load if the store expands or changes its lighting scheme. Therefore, it is essential to ensure that the lighting load is calculated correctly and that the electrical system is sized appropriately. To further illustrate the importance of this requirement, consider a hypothetical example. Suppose a store has a floor area of 10,000 square feet. According to the NEC, the minimum lighting load for this store would be 3 volt amps per square foot multiplied by 10,000 square feet, which equals 30,000 volt amps. This means that the electrical system must be capable of supplying at least 30,000 volt amps to account for the lighting load. If the engineer were to incorrectly specify a lighting load of only 2.3 volt amps per square foot, the calculated lighting load would be only 23,000 volt amps, which is 7,000 volt amps less than the minimum required by the NEC. This difference could have a significant impact on the size of the service and feeder conductors, as well as the size of the overcurrent protection devices. In addition to the minimum lighting load requirement, the NEC also contains other requirements related to store lighting. For example, the NEC specifies requirements for the type of lighting fixtures that can be used in stores, as well as requirements for the control of lighting. These requirements are intended to ensure that store lighting is safe, energy efficient, and effective. It is important to be familiar with all of the NEC requirements related to store lighting in order to ensure that electrical installations comply with the code. In summary, when calculating the lighting load for a store, it is essential to adhere to the following principles. Firstly, use a minimum lighting load of 3 volt amps per square foot. Secondly, do not apply any demand factors to the lighting load. And thirdly, verify that the electrical plans comply with all of the NEC requirements related to store lighting. By following these principles, it is possible to ensure that store lighting systems are safe, reliable, and compliant with the applicable codes and standards. To further elaborate on the NEC requirements related to store lighting, let's delve into some specific sections of the code. Article 220 of the NEC title branch circuit, feeder, and service calculations provides the general rules for calculating electrical loads. Within Article 220, Table 220.3, titled General Lighting Loads by Occupancy, specifically lists the minimum lighting loads for various types of occupancies, including stores. As previously mentioned, the minimum lighting load for stores is 3 volt amps per square foot. It is important to note that Table 220.3 provides minimum values. In some cases, the actual lighting load may be higher than these minimums. For example, if a store uses high-intensity discharge or HID lighting fixtures, the actual lighting load may be significantly higher than 3 volt amps per square foot. In such cases, the electrical system must be sized to accommodate the actual lighting load. In addition to Table 220.3, Article 220 also contains other provisions that are relevant to store lighting. For example, Section 220.12, titled General Lighting, provides rules for calculating the lighting load for areas that are not specifically listed in Table 220.3. This section states that the lighting load for such areas shall be calculated based on the volt amps per square foot specified in Table 220.3 for similar occupancies. Another important section is 220.42, titled General Lighting Demand Factors. This section specifies the demand factors that can be applied to general lighting loads in certain types of occupancies. However, as previously mentioned, demand factors cannot be applied to store lighting loads. It is crucial to carefully review all of the relevant sections of Article 220 in order to ensure that the lighting load calculation for a store is accurate and compliant with the NEC. Beyond Article 220, other articles of the NEC may also be relevant to store lighting. For example, Article 410, titled Luminaires, Lamp Holders, and Lamps, provides requirements for the installation of lighting fixtures. This article covers topics such as the type of wiring that can be used, the mounting of fixtures, and the grounding of fixtures. Another relevant article is Article 700, titled Emergency Systems. This article provides requirements for emergency lighting systems which are often required in stores to provide illumination during power outages. It is important to be familiar with all of the NEC requirements related to store lighting in order to ensure that electrical installations are safe, compliant, and effective. When reviewing electrical plans for a store, it is helpful to have a checklist of items to verify. This checklist should include, firstly, verification that the lighting load calculation is based on 3 volt amps per square foot. Secondly, verification that no demand factors have been applied to the lighting load. Thirdly, verification that the type of lighting fixtures used is appropriate for the application. Fourthly, verification that the lighting fixtures are properly installed and grounded. And fifthly, verification that the emergency lighting system, if required, is compliant with Article 700 of the NEC. By using a checklist, it is possible to ensure that all of the key aspects of the lighting installation are properly addressed. In addition to the NEC, other codes and standards may also be relevant to store lighting. For example, many states and local jurisdictions have their own electrical codes, which may be based on the NEC but may also include additional requirements. It is important to be familiar with the applicable codes and standards in the jurisdiction where the store is located. Furthermore, energy codes may also impose requirements on store lighting. Energy codes are designed to promote energy efficiency and may limit the amount of power that can be used for lighting in stores. These codes may also require the use of specific types of lighting fixtures, such as LED lighting, which are more energy efficient than traditional lighting fixtures. It is important to comply with all applicable energy codes when designing and installing store lighting systems. In conclusion, the NEC provides clear and specific requirements for calculating the lighting load in stores. These requirements are intended to ensure that electrical systems are adequately sized to handle the lighting load and that store lighting is safe, compliant, and effective. By understanding and adhering to these requirements, it is possible to avoid problems such as overloaded circuits, voltage drops, and potential fire hazards. When reviewing electrical plans for a store, it is essential to carefully verify that the lighting load calculation is accurate and compliant with the NEC. If any discrepancies are found, it is important to bring them to the attention of the engineer and require that the plans be revised. By taking these steps, it is possible to ensure that store lighting systems are properly designed and installed. Remember, the minimum lighting load for a store, according to Table 220.3 of the National Electrical Code, is 3 volt-amps per square foot. No demand factors can be applied to this load. This requirement is in place to ensure adequate electrical capacity for lighting, which is crucial for safety and functionality in a store environment. Always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. By following these guidelines, you can ensure compliance and create a safe and efficient lighting system for the store.